Hello everyone. In our last tutorial we have discussed about actors which are similar to classes but they are very thread safe. These concepts called isolated and non-isolated. In this video tutorial we will discuss about async and await, using which we can achieve structured concurrency in Swift. Swift 5.5 has introduced this async and await. If you are a JavaScript guy, async and await these are very well known. Even if you are doing Flutter or even if you are a Java or Python programmer, these asynchronous await operations are very common. So let's get into the details of why these have been introduced and how we usually do asynchronous operations in Swift. So usually, for example, if I have multiple service calls, for example I have a user profile, user preferences and authentications. For example, I need to do multiple operations at a time in a sequence, where I first want to authenticate the user, then I need to fetch the user profile, then only I can fetch the user preferences by passing the user profile. So these sequence of operations earlier we used to do using the callbacks or closures. So there are some pitfalls or disadvantages or not major coming to the readability and maintainability. There are some disadvantages of using callbacks. I wouldn't say disadvantages, but it's pretty much related to readability and maintainability. It's just the understanding. So if you can see, these are the closures. Now callbacks we are doing. If you can see, this is not linear. Linear in the sense it's not step by step. For example, first I will do this, second I will do that. No, it's not a sequence. It's not in a linear fashion. It is, if you can see, each closure adds an indentation. So this will create a callback hell. So we can call it as a callback hell. And also, if you can see, these responses can only be handled by switching over the result. That means the result we are giving in each and every completion block, whether in the authentication, fetch user profile, or in the fetch user preferences, if you can see. So we need to switch over the result to understand, to know the outcome, whether it is success or failure. If it is a success, we need to go for another service call. So that is one thing. Is, let me note down all. So one thing is, nested structure is not readable. It creates something called callback hell. Look at the complexity of this code. One callback inside another completion handler. So this it's not readable. Implementers, we need to switch over the result to get the outcome. It means that the closure returns a result in a way that requires the caller has to handle both success and failure cases explicitly, typically using an enum like result. So when we receive a result, we need to switch over it to handle the different cases. If it is a success, okay, I'll go for another service. If not, I need to handle the error. So this is one thing. So I need to switch over the result to handle something. Until unless I will not be knowing whether what is the result. And also, if you can see, no try catch at implementation level. So here I can't add try and catch. Why? Because these are closures. So only the try catch, only the error handling I can do is from the enum result. If it is failure, here I need to do the error handling. But this is not the traditional way of doing the error handle. We go with try catches. We cannot do try catches. So if there are nested callbacks, I can't do normal. So it's not possible to use try catch statements from the implementation level. Implies that when using closures for asynchronous operations or when returning a result, we cannot directly use try catch to handle errors within the closure itself. We can't do try catches. Instead, we handle errors by checking the result type. If it is failure, we do the error handling. So another disadvantage is no try catch. We can't do, let's say, try catch in the closure. So These are resolved by the introduction of so these are the things usually what we do, but understand it's not linear. One thing is it's not linear. It comes with an indentation. It creates the callback hell one inside other. It's very difficult to debug as well. It's very difficult to debug as well. Why? Because I need to understand I need to understand the complete structure, then only I can debug if something fails. If I am not getting result from this, then I need to go through each and every service call to understand which service is failing and whether the service is giving me the proper response or not. So I need to get through it, which is very difficult. Understand, for example, let's suppose this is the service call 1, this is the service call 2, and this is the service call 3. Imagine I need to add another service call. Let's say that we will become service call 3, and this will become service call 4. So let's say we are going to introduce another service call. Adding another service call within this structure, just imagine. So another thing is changing the adding or editing or deleting the service calls. This is also an issue. So if you can see the code, this is also an issue actually. So one thing always with the closures is we need to take care of memory management. We need to make sure memory management needs to be handled. We generally used weak, self, and this has to be properly taken care. This is one more thing with the closures. Now one more thing is, as we all know, explicitly we need to return the completion in all possible exits. Even if we miss at one place, then the code that is calling the completion handlers will be blocked and it will be infinitely waiting for the completion. So this one, for example, is in each and every possible situation exit we need to call the completion. For example, if it is authenticated, if user doesn't get authenticated, then the code that is calling the authenticate user will have nothing, just simply it will be waiting for this call. So that is one thing. Explicitly we need to return the completion in all possible exits. So these are all different issues that we have with the completion handler, a series of completion handlers if we have. So this is these are the issues, and it's very difficult to reason about in the context of programming also. That means the ability to understand is difficult, the ability to predict how a piece of code behaves and executes when we say, that's also very difficult. Understanding the flow, identifying the dependencies. For example, if this is, I need to go and say, okay, this is depending on user profile, from where I am getting the user profile. Okay, this is the service, this is giving me the user profile. Identifying the dependencies. It involves recognizing the relationship between different parts of the code, such as understanding when one operation depends on result of another. Predicting the behavior, it means predicting the behavior. It means being able to anticipate the outcome of running the code based on structure and inputs. It's not predictable. This includes understanding how different conditions, loops, and functions call interact. I need to understand, okay, if it is success, what I am getting. If it is failure, okay, what is the error that I need to handle. Whether do I need to call this fetch users preferences, fetch user profile again or not, authenticate user again or not. See, this is service call 1, and this is service call 2, and this is service call 3. Imagine you need to add another service call at the end or in between, or you need to remove something. This is not at all predictable. This is not at all easy to read. It is not at all easy to understand. It is not at all easy to predict, and also it is not at all easy to maintain. So okay, these are the issues. Okay, so how these can be resolved, that's where it comes. Structured concurrency in Swift, which is introduced in Swift 5.5. and iOS 15 and above. These concepts are available just for the reference. These are available. And what if I tell you that if I scroll down and show you that there is a way of doing it like this using async and await, right? If you can see, looking at it, you can understand that where is this and where is this. So let me put it so that you will understand. See, imagine, correct? So okay, how it is possible. Now we have made it linear. If you can see, one, there is no indentation, one after the other, 1 2 3. So even if you believe it or not, what we are doing is a bunch of asynchronous operations here. All we are doing is we are just waiting for the service response. So I'll start with async. What is async, and why we are writing in front of why we are writing that as a method attribute. Async is nothing but simply asynchronous. That means this function can run asynchronously, and it can possibly do the suspension. So in this asynchronous function, I can call authenticate user. If you can see, now it becomes async. So that means this is doing an asynchronous operation. Just to simulate it, we have given a sleep. So if it is success or not, we are returning it. If you can see, we have pretty much avoided a thing called result, success and enum, and we don't need to switch over the result to get the outcome. And the error handling also, we are doing it traditionally using the try and catches. So across the application, we don't need to rely on try and catch for synchronous operations and result enum, success and failure for the asynchronous operations. Now we can make it unified error handling we can have across our application code. Even if it is a synchronous operation or asynchronous operation, we can use try and catch, so that you can have an unified error handling mechanism. That is one advantage you can get it with the async and await, as apparently here if you can see the code, it is intuitive. Next, this is one thing. So this is an asynchronous function. So if I am calling it, what I am doing is await. Await is simply nothing but it is waiting for its buddy called async. Okay, it waiting for response from an asynchronous function. The function that does an asynchronous operation called authenticate user. So the program pretty much suspends here. Now we get the authentication token, then I call fetch user profile, then I call fetch user preferences. Finally I get the preferences. Now it has become structured. Now it is for me, it is now very easy to change the order if I want. As we have seen, now I can add easily, I can edit, or I can delete a function call, or anywhere I can change the order, and I can easily understand, I can easily read, it is maintainable, I can predict this response, and I can do the error handling using the try and catch. So these are all, I don't need to switch over the result enum. I directly get the, if I do authentication token, it gives me whether it is successful or failed. Like fetch user profile also, I get directly, I don't get the, if it is these functions throws, so I get the error handling using the try catch. So pretty much it is solving so many things. It is this we call it as structured concurrency. With its it is more linear and predictable flow. It reduces the complexity, nesting, and asynchronous callback chains. This makes it easier for developers to understand, debug, and maintain their code bases. So at a very high level, this is what we call it as structured concurrency. This is how we can achieve the structured concurrency using async and await in Swift, starting from Swift 5.5, and it is available in iOS 15 and later. And we can achieve this by using the async. Async is nothing but a method attribute. Await is the suspension point, we call it as. That means it suspends the execution of the code at this point, and it literally waits for it, and this will not get executed until unless this is done. So like this I can make asynchronous operations in a sequence, in a continuous execution. So what are the benefits of the structured concurrency, if you can ask me? So it's like linear flow. The code reads top to bottom. It's top to bottom. It's not it doesn't need to be indented, but it is not top to bottom. It is like it's like going to your right. Error handling is more straightforward with the do catch blocks around asynchronous calls. Maintainability, the code is more maintainable due to reduced nesting and a more predictable flow of execution. It's very predictable. So by using structured concurrency, we can write asynchronous code that is easier to read, reason about, and maintain compared to using closures for handling asynchronous operation. As we just discussed, maintaining closures comes with these things. If there are multiple closures, it becomes a nested structure that will create a callback hell. We need to switch over the result. Try catches are not possible. We need to rely on result enum. It is very difficult to debug. It is very difficult to add, edit, or delete, or to change the order of the service calls. It will be a nightmare if you have 4 or 5 sequence of service calls. Memory management, we need to be very careful if you are using the closures, that we need to properly handle it, otherwise it will have memory leaks. And explicitly we need to return the completion in all possible exits. We need to be very careful. So this can be avoided using the async. Async stands for asynchronous and can be seen as a method attribute. It's making it clear that a method performs asynchronous work. This authenticate user is doing a asynchronous operation. It might be calling a server and authenticating the user. And await is the keyword used for calling asynchronous method. Await, it is just a keyword used to call the async method. So we can see them as best friends in Swift, as one will never go without the other, and we can say await is awaiting a callback from async. So yeah, that's pretty much structured concurrency and the usage of async and await in Swift. It's very easy to reason about. Methods are linearly executed without going back and forth like you would with closures, and in each closure adds another level of indentation 1, 2, 3, which makes it harder to follow the order of execution. The order of execution is linear and therefore easy to follow, and it's easy to reason about. So yeah, that's pretty much async and await I wanted to discuss as part of this tutorial, which provide a more natural and readable way to work with asynchronous codes, making it easier to write and understand asynchronous operations. So async keyword is used to mark a function or closure as asynchronous. When we mark a function as async, it means that it can perform its operations asynchronously, allowing other code to run concurrently while it waits for the asynchronous operation to complete. Yeah, so this makes asynchronous code sequentiable and readable manner. That is the reason we call it a structured concurrency. And there is one more little very small topic that I would like to cover, which is nothing but async-await. Here comes the use case. What if I don't want to, what if there are sequence of steps? Okay, here is a use case for the async-await. Async-await is simply when we don't need the result of the asynchronous method, when we don't need the result of an asynchronous method immediately and we need it later in our code. That means, for example, let's say fetch. Here I have two asynchronous functions, fetch user profile and fetch user preferences. So I'll for example, this is async. So let's say I want this I use profile is equal to await. In a sequence, if I want to do, I do fetch user profile, okay, with a try, or await fetch user preferences, right these so that we can silence the errors. So this makes it a sequence operations. Why? Because I need profile first and then preferences, then only I'll do first it happens and this happens. So this happens in a serially. What if I don't want what if I it's okay if I'm having these things concurrently. Then here it comes, for example, this is where I can have these things asynchronous. For example, I want to return user profile and user preferences later in my code. So first what I will do is I'll do async-await. So it makes it independent pieces of data concurrently and then use them together. For example, there is a use case where I need to pass these two objects after fetching it. So I don't need it immediately, so I don't await here. That means I don't await here as well. This and this will go concurrently, and I'll await here at once later in the code. Why? Because here I need profile and preferences. So this is the use case of async-await. So instead of waiting for each and every service call, this scenario is different. So one after the other I need it. So I can simply write async-await, which makes independent pieces of data concurrently and then use them together, concurrently initiate multiple asynchronous operations and await the results in a single scope. So this is the use case of async-await. It's a very simple topic but very useful. Let's see another example. Let's say, for example, there is a load image operation I am doing. For example, I want to load images in a sequential order. I use this and I pass this. So image 1 will be loaded first, second will be loaded first. So we can run it and see it actually. Let me put this piece of code at the first, so that, for example, load images. Why? Because this happens one after the other. There is a sleep that I have written, or it's, see, 1 2 3, you run it any number of times. Why? Because this is the suspension point. It has to be loaded, it has to be loaded, it has to be loaded. These three happens in a sequence. Whereas, okay, I don't want to I don't need the sequence actually. So what I need is, I need to send an array, build an array. I want to use the responses later in the scope. So in that case, I don't literally worry about the order of this image's execution. This will, then I'll put async-await. So and I'll await for the result. So if we can run and see this, you can see the order. I'll comment this. We can see the order of images could be anything, 2 3 1. It could be 2 1 3, right? So I can change the sequence and I can only wait for the complete response here. So that's async-await. So I hope this tutorial is useful, where we have discussed pretty much about structured concurrency. We can achieve this using async and await. We have discussed various challenges with the closures, like nested structures are very creates callback hell. We need to switch out the result. No try catch, we can't. It's very difficult to debug, read, understand, predict the behavior. Memory management needs to be strictly done if you're using the completion handlers, and explicitly we need to return the completion in all possible exits. And whereas coming with async and await, we can have this structured concurrency. We can make it linear, no indentation, nothing, and it is easy to read, predictable, understand the dependencies. It is very easy to change the order. So actually this, we are doing an asynchronous operations, but if you can see, we are doing it step by step, one after the other, one after the other. For example, here again, if we don't need these operations to have in a sequence, but at the end we need all this. Again, we can, instead of waiting at each and every service call, we can go with async-await, which we just discussed. Okay, that's all for this video tutorial. I hope this video is useful. Thank you so much.